Hi everybody, I'm going to talk to you about the seasons. Um, let's take a look at this view. I'm using your simulator, um, Starry Night. What you're looking at here, first of all, take a look. It's December 21st. It's 2001, but it really doesn't matter. We take a look. The Earth is in its orbit around the Sun, and since it's December 21st, that's called the winter solstice. And you can see that the overhead sun is shining most directly on the southern hemisphere. It's about 23.5 degrees below sunlight. Now let's take a look at what the sky would look like at noon in Olympia, Washington, which is in the northern hemisphere. Okay, so here we are. This is the winter solstice. This line here, the pink line that you see, uh, that line is the celestial equator, and it at Olympia has a latitude of 42.2. Let me check that. 47.2 has a latitude of 47.2, and if you subtract 47.2 from 90, you will see that it's about 42 and a half or so, and that's exactly where that celestial equator lies. What I'm doing is I'm looking south, and the celestial equator will be 90 minus my latitude above the southern horizon. And if we go back and take a look at the seasons, you can see why that would be. Okay, uh, the celestial equator is just an extension of the Earth's equator onto the celestial sphere. And so when you're on the Earth's equator, the celestial sphere's equator will be at the horizon. I'm sorry, it will not be at the horizon. It will be directly overhead. If you're on the North Pole, the celestial equator will be at the horizon. And if you're in between, then the celestial equator can be found by subtracting your latitude from 90 degrees. Okay, so we're talking about the seasons. The winter solstice here, at the winter solstice, because the Earth is tilting, the northern hemisphere is tilting away from the sun. The sun will the most direct rays of the sun will be below the equator. And since we are tilted 23.5 degrees, if we take a look at and use the angular separation tool, we can actually measure the distance in the angular separation between the celestial equator and where the sun is. And you can see it's 23 to 24 degrees, depending on where I pick my point. Basically 23.5 degrees below the celestial equator. And if we go back, we can see here's the Earth's equator, and that just the celestial equator is just a projection of the Earth's equator onto the celestial sphere. And you can see that at the winter solstice, the direct line of the sun is below that equator line. And so the sun is it is low in the sky during the winter. Okay, so let's go ahead and advance this. What we're going to be doing is we are going to be I'm going to advance the time of viewing 1 day per click. And as I do this, if you take a look at the date, so for example, I use the step forward button. That's the 22nd, 23rd, 24th, 25th, 26th. And as I do this, notice that the sun, the noonday sun, gets higher in the sky. Until on March 22nd, this would be the vernal equinox. This is the beginning of spring. And on the beginning of spring, what you'll notice that the sun lies directly on the celestial equator. And okay, so if we continue to advance, okay, this is the first day of spring. That's called the vernal equinox. If we continue to advance to June, you notice that the days were going to get longer in the northern hemisphere because we are now above the celestial equator. And if we take a look, let's see, we would need to go to May 3rd. Now, we're not going to be able to see it very well here because the Earth will be eclipsing the sun. But on March 22nd, you can see that the Earth is tilted on its axis, but because it's in the middle part of its orbit, it's neither tilting away nor towards the sun, and so the sun's rays are hitting the Earth's equator directly at noontime. They're perpendicular, and so we have the same number of hours of sunlight in the northern and southern hemisphere. So March 22nd, which is the vernal equinox, is the first day of spring. And if we go ahead and bring it forward, we come to the first day of summer, which is June 22nd, also known as the summer solstice. Now notice here, the sun will be higher in the sky because in the northern hemisphere. And if we take a look on June 23rd, you can see that the sun is continually rising in the sky. There. So now we have the summer solstice. And after the summer solstice, the days get shorter. And if we would let this then go to September 21st, 22nd, the noonday sun falls in the sky until we line up, and now we have the autumnal equinox. And then we repeat the cycle each year. If I let it go ahead and go, we'll go to the winter solstice. and that's how that's an explanation of how the seasons and the noonday sun change.